Now, a slightly more complex type of analysis of variance is the n-way or factorial analysis of variance, where the n represents the number of factors. So in this case, we have more than one factor whose variance we're analyzing. In marketing research, one is often concerned with the effect of more than one factor simultaneously. For example, how do the consumer's intentions to buy a brand vary with different levels of price and different levels of distribution? How do advertising levels, high, medium, and low, interact with price levels, high, medium, and low, to influence a brand's sales? What is the effect of consumers' familiarity with a department store, high, medium, and low, and store image, positive, neutral, and negative, on preference for the store? In determining such effects, n-way analysis of variance can be used. A major advantage of this technique is that it enables the researcher to examine interactions between the factors. Interactions occur when the effect of one factor on the dependent variable depends on the level or category of the other factors. The procedure for conducting n-way analysis of variance is similar to that for one-way analysis of variance. The statistics associated with n-way analysis of variance are also defined similarly. We will once again use the department store example to illustrate this analytical technique. In this case now we have added a second factor, so we have a two-way analysis of variance situation. In addition to the in-store promotion levels of low, medium, and high, now we also have the coupon level. Couponing was manipulated at two levels. Either a $20 store-wide coupon was distributed to potential shoppers, this is denoted by the categorical value of 1, or the coupon was not distributed, denoted by the value of 2. In-store promotion and couponing were crossed, resulting in a 3x2 design with 6 cells. What we mean by crossed is that the in-store promotion levels of low, medium, and high each had a coupon level of either 1 or 2. So we see, for example, we have the treatment of in-store promotion level 1 and coupon level 1, in-store promotion level 2, coupon level 1, in-store promotion level 3, coupon level 1, and then in-store promotion level 1 again, but now with coupon level 2, in-store promotion level 2 with coupon level 2, and in-store promotion level 3 with coupon level 2. This is what we mean by the factors being crossed. As a result, we have 6 group means that we will be comparing. The null hypothesis is that there is no difference between the means, which would indicate that the two independent variables have no effect on the dependent variable, meaning the coupon level and in-store promotion and its interaction, which we'll talk about in a bit, do not influence sales. Here we see the results or the output of our two-way analysis of variance. It's similar to the one-way analysis of variance, only now we have added 2 components. We have the second factor, and then we have their two-way interaction of the 2 factors. I'll describe this more in just a moment. So the main effect is the independent effect of each individual independent variable. So we have promotion, which we see here, the F statistic and the significance level of 0, 0, 0, which is less than our significance level of 0.05. Therefore, we reject the null hypothesis, and we conclude that promotion does affect sales. The second main effect is of store couponing. We see again that we can reject the null hypothesis that couponing has no effect on sales. And then we have what's called the two-way interaction, which in this case we accept the null hypothesis that the interaction has no effect on sales. A commonly used measure in ANOVA is omega squared. This measure indicates what proportion of the variation in the dependent variable is related to a particular independent variable or factor. As a guide to interpreting, a large experimental effect produces an index, or omega squared, of 0.15 or greater. A medium effect produces an index of around 0.06, and a small effect produces an index of 0.01. In this table, while the effect of promotion and couponing are both large, the effect of promotion is much larger. As I mentioned earlier, an interaction effect occurs when the effect of an independent variable on the dependent variable is different for different categories or level of another independent variable. So, for example, if the interaction had been significant here, an example of an interaction would be to say that when no coupon is offered, then a high level of in-store promotion produces greater sales than a low level of in-store promotion. However, if a store coupon is offered, then the opposite occurs, and a high level of in-store promotion results in lower sales than a low level of in-store promotion. Analysis of covariance. When examining the differences in the mean values of the dependent variable related to the effect of the controlled independent variables, it is often necessary to take into account the influence of uncontrolled independent variables. For example, in determining how consumers' intentions to buy a brand vary with different levels of price, attitude toward the brand may have to be taken into consideration. In determining how different groups exposed to different commercials evaluate a brand, it may be necessary to control for prior knowledge. In determining how different price levels will affect a household's cereal consumption, it may be essential to take household size into account. In such cases, analysis of covariance should be used. Analysis of covariance includes at least one categorical independent variable and at least one interval or metric independent variable. The categorical independent variable is called a factor, whereas the metric independent variable is called a covariate. The most common use of the covariate is to remove extraneous variation from the dependent variable because the effects of the factors are of major concern. The variation in the dependent variable due to the covariates is removed by an adjustment of the dependent variable's mean value within each treatment condition. An analysis of variance is then performed on the adjusted scores. The significance of the combined effect of the covariates, as well as the effect of each covariate, is tested by using the appropriate f-tests. The coefficients for the covariates provide insights into the effect that the covariates exert on the dependent variable. Analysis of covariance is most useful when the covariate is linearly related to the dependent variable and is not related to the factors. Again, we'll use the illustration of the department store experiment. Suppose that we wanted to determine the effect of in-store promotion and couponing on sales while controlling for the effect of clientele affluence. It is felt that the affluence of the clientele may also have an effect on sales of the department store. The dependent variable consists of store sales. Just as before, promotion has 3 levels and couponing has 2. Clientele was measured on an interval scale and serves as the covariate. The results are shown in this table. As you can see, the sum of squares attributable to the covariate is very small, with 1 degree of freedom resulting in an identical value for the mean square. The associated F statistic is also small, and it is not significant at the 0.05 level. Thus, the conclusion is that the affluence of the clientele does not have an effect on the sales of the department store. If the effect of the covariate is significant, the sign of the raw coefficient can be used to interpret the direction of the effect on the dependent variable. Next, I will conduct a demonstration using SPSS to carry out an analysis of covariance. Here we have the steps required to conduct an analysis of covariance with SPSS. You select Analyze from the SPSS menu bar, click General Linear Model and then Univariate. Then we move our dependent variable sales into the dependent variable box. Then we move our independent variable in-store promotion to the fixed factors box. Then we move our second factor, coupon, to the fixed factors box. Then we move our covariate, clientele, to the covariate box, and then we click OK. First we select Analyze from the menu bar, then General Linear Model, Univariate. Our dependent variable is sales. Our independent variables are the factors, and it is in-store promotion and couponing. And now we will add the covariate of clientele affluence. Then we click OK. The output that we have here gives us the ANOVA table, where we have the different sources of variation. Here we have the covariate, here we have the in-store promotion variable, the couponing variable, and their interaction. Just as we saw earlier, the interaction is not statistically significant. However, the effects of couponing and in-store promotion are. And as we can see, the effect of clientele is also not statistically significant. Just as before, the conclusion is that the affluence of the clientele does not have an effect on the sales of the department store. If the effect of the covariate was significant, we would use the sign of the raw coefficient right here to interpret the direction of the effect on the dependent variable. Now remember that the F-test simply tells us if there's any difference in any pair of means. It does not tell us which means are significantly different from each other. Here we see the resulting means from the two-way analysis of variance from our department store example. Here are the cell means that are crossed, meaning the in-store promotion levels are crossed with the couponing levels. We have 6 cell means here. We would only examine this if the interaction of in-store promotion and couponing, our two factors, was statistically significant. But since the effect of the interaction was not significant, that means there's no pattern here to observe. We will focus instead on the factor level means. So these are the means associated with each independent variable separate. So looking at just the effect of in-store promotion, high, medium, and low, we have the mean sales. And looking at just the effect of couponing, we have the mean sales here. Now once again, the F statistic only tells us that there was a difference. So in the case of promotion, which was statistically significant, at least one pair of means was statistically different, but we don't know which one. Now it's a little bit easier to interpret the coupon factor because there's only 2 groups. So the fact that there was a statistically significant difference tells us that this, which is the only pair, was different. So we can interpret this as couponing produced higher sales than not couponing. So how do we find out which mean is different from the other? This can be done by specifying appropriate contrasts or comparisons used to determine which of the means are statistically different. A priori contrasts are determined before conducting the analysis based on the researcher's theoretical framework. So the researcher might come into the analysis before conducting it and already have in mind what the pattern of means will be. Perhaps the researcher already suspected that a low level of promotion will result in lower sales than a medium level, and that a medium level will result in lower sales than a high level. Then the contrast test is only conducted if the ANOVA-F test is significant. Now, if the researcher has no idea what the relationship between the means will be and which ones will be different, then he or she should use a posteriori contrasts, which are called post hoc tests. These are made after the analysis. These are generally multiple comparison tests. They enable the researcher to construct generalized confidence intervals that can be used to make pairwise comparisons of all the treatment means. The Chaffee test is the most conservative. Now I will demonstrate how to conduct the post hoc test using SPSS. So we will conduct the two-way analysis of variance again. We will ignore the covariate. Sales is our dependent variable, and our fixed factors, which are the independent variables, is in-store promotion and couponing. And we will click on post hoc. Now remember, we already know that since there's only two groups for the coupon variable, we can determine which means are different. But for promotion, where we have three categories, we need the post hoc test. We will select Chaffee and click Continue. Then we click OK. Here we have the output. This is the same ANOVA table that we saw before. And now we have here the multiple comparisons, or the post hoc procedure for in-store promotion. And so the Chaffee test tests each pair of means to find out which ones are statistically significant in difference from each other. And as we can see here, all three sets and all three pairs of means are significantly different from one another. To interpret that result, we would look at the means again, and we know that they're all different from each other, so we can conclude that a low level of in-store promotion produces lower sales than a medium level of promotion, and a medium level of in-store promotion produces lower sales than a high level of in-store promotion. Consequently, a high level of in-store promotion produces greater sales than a low level of in-store promotion.